So thermal energy is transferred in three different ways depending upon the type of material that we're using. The three types are conduction, convection, and radiation. Conduction and convection are medium dependent, that it would require some medium for transfer of thermal energy, whereas radiation is medium independent. When it comes to conduction, conduction occurs in solids. And conduction is defined as the transfer of thermal energy by vibration of particle to particle. That is, if we have these particles in solid, energy is given to this. So due to the vibration, it would exchange its energy to the neighboring particle and then to the neighboring particle and then to the neighboring particle. Eventually, it will be shared to the last particle. When we are discussing conduction, we discuss the type of material, the type of solid that we're transferring energy into. And when it comes to that, we discuss it in terms of conductors and insulator. Conductors, and in both conductors and insulator, the mode of transfer of energy is exactly like this, that particle to particles. But when it comes to conductor, we have an added advantage of free electrons. So as the energy is transferred from particle to particle, at the same time, the free electrons, the mobile electrons that are present there, they would also exchange energy. So conductors heat up faster as that of insulators due to these free electrons. The phenomenon is exactly the same, that the energy would be transferred from particle to particle. And then there is this experiment normally that we discuss, and that is, okay, how can we find out which is a better conductor and insulator? So we would take rods of equal length of different materials and diameters. We would attach wax to each rod and we'll start heating it from the same end. So the rod which would get जिसका wax melt हो जाएगा first, that would be the better conductor, and whose wax would melt at last would be the insulator. We can also attach paper clips to it. So the one in which the paper clips falls fastly, that would be a better conductor than as compared to the one जिसमें बिल्कुल last में जो है वो paper clips जो है वो fall down होंगे. Are you clear about conduction? Then comes the second mode of transfer of thermal energy, which is convection. We discuss convection because when we applied the phenomena of conduction to fluids, we saw that it's not the efficient mode of transfer of energy. How did we know that? Okay, the experiment that we discussed was that we took a test tube, we filled it with water, and we placed an ice cube at the bottom of the test tube, and we started heating it from this end. And we saw that the water at this end started boiling, yet the ice was still to be melted. From there, we came to know that it's not the efficient mode of transfer of energy when it comes to fluids. Because what was the reason behind that? Because in fluids, the particles are further away from each other. So it's not possible for them to exchange their energy to the neighboring particle efficiently. And then we discussed in another experiment in which we filled it with water and we put crystals of KMNO4 at the bottom of the beaker. After some time, we saw that stream of color was going up. That showed that particle itself is moving to the neighboring particle or neighboring atom to exchange its energy. So, we defined convection as the mode of transfer of energy in which the particle itself moves to exchange energy. Convection is feasible for both liquids and gases. As the particle itself is moving and exchanging its energy, so both in gases and liquids, this is the efficient mode of transfer of energy. Then we discussed another experiment in which we discussed about the convection current. कन्वेक्शन करंट को हमने कैसे डिफाइन किया था? The movement of hot and cold air particles or particles, just particles. Current is defined as the movement of particles and convection is as the energy is being transferred. So when it comes to convection current, we discussed that hot particles having greater kinetic energy would vibrate more violently and exchange its energy faster. As compared to the cold particle, which has less kinetic energy, so energy transfer would be slower or low. At the same time, the hot particles, the particles which has gain energy, would expand and will become less dense. As per the formula of density, which is equals to mass per unit volume. As expansion is occurring, this means volume would increase and density would decrease. And due to this, hot particle would move upward. When the hot particle would move upward, a cold particle being less dense, more dense, would go downward and would displace hot particle. Cold particle has more density because their volume are less, their particles are closer together, so it would be more dense. So this movement of hot and cold air particle is known as convection current. This convection current has many application. Wind is due to convection current. heating or cooling of the room is due to convection current, because normally heaters are placed at the bottom and AC are placed at the top. What is the reason behind that? Heaters are placed at the bottom because cold particle being more dense are present at the bottom. So when the cold particle will come in contact with the heaters, they will become hot and will become less dense and would move upward. So eventually when all of the cold particles are heated, so the room will become temperature of the room will become higher. On the contrary, when we're talking about AC, air conditioners, we know that K hot particles are present at the top. So the AC would cool those particles, and being the cold particles they would move down, and eventually all of the air particles will become cold, and eventually the temperature of the room would decrease. That's how convection current, or the meaning of or the mode of transfer of convection, would help us to understand these two phenomena, that why do we do this, and the one that we have just done in the workbook, the chimney one. This experiment is basically designed to validate that convection current is real, and real in terms like the heated particles would go up and the cold particles would go down. In this experiment, we usually take a candle on one side and visible smoke on the other side. And we would observe that the visible smoke is going down from here and going up from here. And why is that? That these air particles are colder than these air particles. So whenever a heated particle would go up, it would be displaced by a cold particle, and eventually that cold particle will be heated up by the candle and would go up. So this movement of the particles would justify the convection current, that the cold particles being more dense would go down and heated particle would go up from the candle side. So the last mode of transfer of energy is radiation. Radiation is a mode of transfer of thermal energy in the form of electromagnetic radiations. And this type of transfer of energy would not require any medium. And the example for radiation is the heat coming from the sun. As there is space in between Earth and sun, and if the heat is coming to Earth, which means that there is some form of transfer of thermal energy which is medium independent. And this mode of transfer of thermal energy is in the form of electromagnetic radiations. And these electromagnetic radiations are mostly referred to as infrared rays. You might have heard this term before. Infrared rays. नाइट विन कैमरास के अंदर we use this technology. The people would see green or red when in the dark, because every body emits infrared radiations. And the intensity of infrared radiation would depend on the temperature. The higher the temperature, the more intense infrared would be emitted of shorter wavelength. More visible the image would be when we are viewing it through the night vision camera. So normally ये सन की एग्जांपल कोई जो वैलिडेट किया जाता है Okay, when it comes to the third form of thermal energy, that type of thermal energy is medium independent. When it comes to radiation, we discuss colors as well. We know that K different colors have different capabilities of absorbing or losing the energy. So there comes three terms: emitter, absorber, and reflector. So normally darker colors or black are good emitter and absorber, and shiny surfaces are good. Shiny surfaces जो है वो good reflectors होती हैं हमारे पास. ठीक है? So if we have a box like this with each side of different color and shade. One is black, one is dull black, one is shiny black, one is white, one is silver, reflective surface, I mean. And at the bottom, there would be an hollow medium, उसमें हम लोग hot water put कर देंगे या heater put कर देंगे. And on either side हम एक radiation detector लगा देंगे और IR detector लगा देंगे. So we would observe that which detector would have the highest reading? Which detector would have the highest reading of radiations? Sorry?
You asked which one would have the higher?
Reading of radiation. Which side? Which color would have the highest radiation reading?
Black.
Yes, because black is both a better emitter and absorber. It would get heated faster and at the same time will become colder as well. It could emit and absorb both at a faster rate. And least reading किसकी होगी? Shiny surface की और shiny reflective surface की. That is why in summers we wear light colors and in winters we wear normally darker colors because they help us to keep our body temperature at a particular value. Okay? So these are the three modes of transfer of energy and how energy is transferred when it comes to solid, liquid, and gas. And the last phenomena we already have discussed, which was okay, how to calculate the energy transferred. What was the formula for that? Specific heat capacity. कैसे define किया था हमने उसको? Specific heat capacity is defined as the amount of energy required to raise the temperature of 1 kilogram of a substance through 1 Kelvin or degree C. If I have these two blocks, each of 1 kilogram, with a thermometer placed in it, and for now they have a temperature of 23 degrees C. So the amount of energy required to raise their temperature to 24 would be known as specific heat capacity. Here another thing we need to keep in our mind that materials with high specific heat capacity gets heated and cooled faster as compared to the substances with low specific heat capacity. तो low specific heat capacity होगी वो it would take time for them to heat up and to cool down, and the one with high specific heat capacity would take time to cool down and sorry would take time to heat up and also would take time for them to cool down. I think so मैंने opposite लिख दिया. They will take time for heating and getting cold with substance having high specific heat capacity as compared to, so the metals जो होते हैं they have low specific heat capacities, and why is that? Because वो easily heat up and cool down हो जाते हैं, whereas on the other side the materials which will get normally water की example ली जाती है, that water has high specific heat capacity with a value of 4200 joules per kilogram degree C. So water has high specific heat capacity, which means that it will take time for water to heat up and to cool down. Okay? And the formula for specific heat capacity is given as energy is equals to mass times specific heat capacity times difference of temperature. So उसका difference of temperature कितना था? 1 degree C. Amount of substance कितना था? 1 kilogram. So in order, let me redraw the diagram. So in order to use this formula, energy is equals to mass into specific heat capacity into temperature, we would need to measure these values in order to find out the specific heat capacity, which would be equals to E over M into delta T. Suppose we have a substance of a certain mass, which we have measured using a digital balance. It would be totally enclosed in some kind of insulation so that all of the heat which is given to the substance would heat up the substance. We would attach a heater to it, and to the heater we would attach a battery and an emitter and a voltmeter. Voltmeter would measure the voltage taken by the heater. Emitter connected in series would measure the current, and we will use a stopwatch to find out the time. In one of the formula, energy is given as voltage times current times time. So with the help of these two meters, we would measure the voltage and current, and with the help of stopwatch, we would measure the time. Suppose for 30 seconds, we would see the value of current and voltage that is being drawn by the heater. We'll multiply it with 30 and we will find the value of E. We would put that here. We already have found the value of mass to be measured using a, and we will also attach a thermometer in that substance which would give us the value of temperature. So before starting the heater, we will note the initial temperature, and after 30 seconds we would note the final temperature. So the difference of temperature, whatever the value would be, we'll put it here and we'll get the specific heat capacity of the substance, which is the amount of heat energy required to raise the temperature of 1 kilogram of substance to 1 Kelvin. That is it for today. We discussed convection, radiation, and conduction in the previous lesson. There are a few points that are related to convection, which are the thermal gladiators and the land breeze and the sea breeze. Sea breeze is the one which is present in the morning time, and land breeze is the one which occurs in the uh, nighttime. So we could see here that on a hot day, the sun heats the land. Land is solid and heats up much more quickly than that of water. कल भी हमने discuss किया था कि water has a high specific heat capacity, which means it would take longer for it to heat up and cool down. On the contrary, जो land होती है, it's heats up quickly and cools down. So If on a hot day, if the land is getting hotter faster, which means the air above the land would also become warm and will move towards the colder region. So due to this movement of air from land to uh, sea or water whatsoever which is nearby, this is known as sea breeze, and this again occurs due to the convection current, sorry. And the inland breeze, as the water heats up and cool down slowly, so the at night the air above the water would heat up and would move towards the land where the air is comparatively cooler. So movement of air would be from sea to the land. So this would be known as land breeze. And there is a term used as thermal gladiators. Thermal gladiators would use the working of convection current. They will flap their wings, and due to that flapping, convection current create hoga and circulation of air hoga, which would help them to fly for a longer period of time without flapping their wings. So such birds are known as, or this phenomena the such birds are known as thermal gladiators, which uses the phenomena of convection current, which is by flapping their wings, they create convection current, and due to that convection current, they are able to fly for a longer time without uh, flapping their wings. Okay, and then there
I
is a
can't hear you
phenomena.
anymore if you're speaking.
Sorry, can you hear me now?
Hello? Yeah.
Can you hear me now? Then comes the phenomena of evaporation, which is related to the thermal energy transfers. So when it comes to that, I don't need this one. I need, yes, this board. So evaporation, sorry, evaporation is defined as the sudden escape of particle into air. Why this occurred? Because the particles, water particles or liquid particles at the surface would gain enough kinetic energy to leave the surface, leaving behind low energy particles. And we know that कि हमने discuss किया था कि kinetic energy is proportional to the temperature. So if kinetic energy is bigger, which means temperature is high. If kinetic energy is low, the temperature is low. So if the particles with higher kinetic energy has left the surface of the liquid, leaving behind low energy particles, so that's why evaporation causes cooling. So evaporation की वजह से क्या होता है? One feels cold. जैसे normally when we take shower, we get out of the swimming pool, we feel cold. Why is that? Because the water particles on our body absorbs the heat from our body and will gain kinetic energy and will leave the body, our surface. So leaving behind low energy particles which are colder in temperature, so we feel cold. So evaporation causes cooling. The rate of evaporation is dependent on the following factors. First and foremost is temperature. And also one thing keep in your mind, I'll discuss that in the difference between evaporation and boiling point again. So evaporation depends on temperature. If the temperature is greater, rate of evaporation would be greater. If the surface area is big, that is, we have a bigger container versus a smaller container with a smaller surface area. So the one with the greater surface area, the water would evaporate faster. Third is depth, inversely proportional to depth. If some media, if the container is shallower, water would evaporate faster from it as compared to the deeper one. सो डेप्थ से वो इनवर्सली प्रोपोर्शनल है, इन दो के साथ डायरेक्टली प्रोपोर्शनल है। डेप्थ के साथ evaporation rate of evaporation is inversely proportional. That is, if we increase the depth of the container, the rate of evaporation would be slower. And last is drought. Drought is wind. We know that when there is wind, the rate of evaporation is faster as compared to the one with without wind or lesser wind. And humidity से भी evaporation rate जो है वो decrease होता है. If this humidity rate is bigger, तो evaporation क्या हो जाएगी? Automatically lower हो जाएगा हमारे पास. Are we clear about the evaporation and the points that are related to it?
Yeah.
Can I go to the next one?
Yeah.
Then there is a point where we discuss the difference between evaporation, because evaporation is normally discussed in context with the boiling point. So the major difference between these two is evaporation occurs at all temperature, whereas boiling occur at fixed temperature. Second point is evaporation occurs at surface only. That is what particles would escape from the surface only, whereas boiling occurs throughout the liquid. Evaporation causes cooling, whereas boiling would increase the temperature of the surrounding. And when boiling occurs, bubbles are produced. We'll see the bubble going up the liquid when boiling is occurring. And last is change of state. Boiling, we already have discussed, occurs at the fixed temperature. So we already have discussed in the kinetic molecular theory that when change of state is occurring, temperature of the system remains constant, because all of the temperature or heat energy given is utilized to break the or weaken the intermolecular forces. That's why if we're giving heat to a system, that heat would not increase the temperature of the system, rather it would be utilized to make the intermolecular forces between the particles to change of state. जो हमने heating and cooling curves में पढ़ा था ना, कि we get two flat lines in heating curve. This is melting point and this is boiling point. And why do we get these straight lines? Because the energy given at these points would be utilized to change the state of the substance. Okay?